ABM 11D, and today I will be talking about the functions in context of civil engineering. Civil engineering is consistent of building, conceiving, constructing, and maintaining infrastructures from public and private sectors like bridges, roads, buildings, and systems of water supply and sewage.
Hello, I'm Miguel from ABM 11D, and today we will be talking about 4 different functions in context of civil engineering. So first, we will be talking about the polynomials. The polynomial f of x equals x plus 25. So why is it considered a polynomial? 1, it is a linear function, meaning its highest exponent will be 1. With this function, we will be tackling the height of a certain building in regards or in comparison to other buildings. So, if you would ask, what are the parameters, the independent and dependent variable of this equation, of this function? So first, the parameter would be this 25. The 25 would be the height of building 1. Next would be the independent variable. The independent variable x would be the difference of the height of building 1 and 2. Finally, for the independent variable, it would be f of x, or we can change it as y. Y as the height of building number 3. Next would be the domain and range of this function in regards to the context of civil engineering. So first, the domain of this function, if it's not including the context of civil engineering, would be all real numbers. However, we can assume that the smallest building an average civil engineer would make will be 12 feet. So the range of these functions would range from negative 13 to positive infinity. While the range of this function would be 12 to positive infinity. Next will be the inverse of this function. The first, f of x equals x plus 25. We would first substitute f of x with y equals x plus 25. Then we would change the position of x and y. X equals y plus 25. After getting this, we should isolate now y through adding negative 25 to both sides. So, x minus 25 equals y. Changing y into f of x raised to negative 1 gives us x minus 25 as the inverse. So now for the graph of this function. This is not the exact graph of the function. We just assume that if the x would be positive, this would be the graph, given that the range should start from 26. It is a linear function, meaning its graph would be a line. However, given that the domain of this function is only up to negative 13 and the range would only up to be positive 12, you could assume that the graph would go from here up to there with the line. The graph also doesn't have any zeros nor asymptotes. So what if we change the equality sign to an inequality one? For example, for a function, we chose that x plus 25 greater than 21. So the domain we will be getting would be x greater than negative 4. The interval notation for this function would be negative 4 to positive infinity, this excluding negative 4. The graph would be from negative 4 to positive infinity excluding negative 4. So what if we introduce another operation to this function? Our suggested operation would be g of f of x equals, g of x equals x plus 17 all over. So solving for this, we should first get f of x. So again, f of x equals, f of x equals x plus 25. With the domain from negative 13 to positive infinity. This would give us the lowest range of 12 to positive infinity. Knowing that 12 would be the lowest range, we could now assume that the lowest x we could use for g of x would be 12. So 12 plus 17 equals 2, over 2, which should give us 29 over 2 or 14/5. In the context of civil engineering, what can be made of these functions? These functions could now represent the height of building number 3. Given that the height of building number 3 means the half of building number 2 plus 7
would be the trigonometric functions. In this topic, we will be using the function f of x equals tangent of x over 20 raised to negative 1. This function could be related to civil engineering because of the fact that we will be using this function in order to find the distance of a building to a person. This is a trigonometric function because of the presence of the term tangent, also known as one of the trigonometric parameters of this function, also known as the given, is the 20. While the independent variable is the x, and the dependent variable is the f of x or y. With the angles of a triangle equivalent to 180, it only means that the value of x could only be in between 0 to 90, with 0 to 90 and with 0 and 90 not included, because of the fact that 90 is already given as an angle and the value of x could only be 1 to 89. Now, which gives us the domain, which is 0 to 90, and the range being 0.349101296 until 1145.79923. The inverse function of this trigonometric function is f raised to negative 1 a function x equals tangent of x over 20 raised to 1. The explanation to that is because of the fact that when you reciprocate tangent of x over 20 raised to negative 1, you would only change the sign of negative 1 into positive, which gives us tangent of x over 20 raised to 1.
This is the graph of the function f of x is equal to tangent x all over 20 raised to negative 1. The graph basically shows that if the person is nearer from the building, then his point of view or the angle where he sees the topmost edge of the building would be smaller. As for the zeros and asymptotes of the graph, there is none, given that the graph is only a linear graph.
If this function would be changed into an inequality, let's say 50 would be less than tangent x over 20 raised to negative 1, therefore, x would be less than. Graphing this into the number line would give us But this would
At
end at
0, given that there is no angle which is less than or equal to 0.
If we were to use an operation to this function, let's say g of f of x, wherein g of x is equal to x plus 50, let's say the minimum of this function would be 50. Therefore, the total distance would be x plus 50.
Hi, I'm Michael Hunter B. Shoebridge,
And that's cool.
and today we will be talking about rational functions with its context in civil engineering. The parameter of this function are this, and the first parameter is couple moment at the right side, which is equal to 10 Newton per millimeter. Moment of inertia equal to 10 millimeter raised to 4. Length of beam, which is 5 millimeters, and elastic modulus, which is 10 newtons per newton millimeter squared. Now the dependent variable is slope at free end, which is equal to y, and the independent variable is the value of x. Now, the domain of this function is all reals except -1/5 and 0, while the range are all reals except 0 and 2.
The graph of 20x squared over 2x plus 5x times 2x is this. Zeros are none, and the vertical asymptote is x is equal to -1/5 and x is equal to 0. And the horizontal asymptote is y is equal to 2. Using this solution to find the inequality, which is 20x squared over 2x plus 5x times 2x is greater than 2, we'll get the solution set of -infinity and -1/5. Get the difference of the two slopes of the two cantilever beams. We have to subtract the values of gx, which is 20x squared over 2x plus 10x times 2x, minus the value of f of x, which is 20x squared over 2x plus 5x times 2x.
So, I'm Julio Gandia, and I'm going to talk about the exponential functions in context of engineering. So, after further research, we chose the exponential decay model, which we can use for our radioactive decay. This is the decay of particles over time. So, the equation is n is equal to n times e raised to k negative kt over t sub 1/2. Our y here is the number of particles, or the n, and our x is the time. Our t sub 1/2 is the half-life of the particle, which we are going to use the carbon-14 particle, which is related to engineering, which we can relate, which is the particle that we can relate to engineering. The half-life of that particle is 5,730, while n is the initial amount of particles, and k is our decay rate, which is 69.3%. Now, by adding the values, this is the equation. So 200e raised to negative 0.693 x over 5,730. This is our radioactive decay for a carbon-14 particle. So for the domain and range for our exponential function, the domain is 5,730 positive infinity. So why is it 5,730? So 5,730 indicates the half-life, and carbon-14 is not stable. So we cannot calculate the age of a carbon-40 particle if it is less than 5,730. So, and the range is 0 to positive infinity. Inverse of the exponential function is negative 8,268.398 3,982 thousandths ln 0.005x. With the help of Desmos, this was the graph of the exponential function. As you can see, the graph slowly goes down but does not touch zero. It looks like it touches zero, but the intervals are long, so that's why it looks like the graph touches zero. It shows the decay from here and how that particle decays over time. From the graph I showed earlier, it shows that the exponential function does not have zeros, it does not have a vertical asymptote, but it has an horizontal asymptote, which is y is equal to 0. You can see that the graph does not touch 0. For the exponential, the inequality, we use the formula 200e raised to negative 0.6993 x over 5,730. We change it to a greater than sign, and we change 0 to 1. 1 is in the range, so we used 1. So for the solution set, negative infinity to 1,910,000 over 231 times ln 203. So for the operation, I used subtraction. I created another function which I changed the n, which is 300, compared to 200. So this means that we can show the difference of the two carbon-14 particles which have different present particles. How does this affect the y? We can see how does this affect y?